Welcome to Bite-Size Data Science. We're still in the data science lifecycle, this time in data collection. There's a lot to talk about here. Let's get started. We saw in the data requirement video that data comes from internal and external sources. We need to be able to keep track of that data and protect it properly. Even for a relatively small number of data sources, the transformation that may be required will multiply the number of data sources. It would make sense to use tooling that allows for cataloging the data. The second issue with data sources relates to security and privacy. We need to be able to control access to the data and protect personally identifiable information. Ideally, the tool used would reference the original data instead of making copies and allow for masking and encoding PII data. The main topic I want to cover in this video relates to big data. Do you have to worry about big data? What qualifies as big data? It is partly a matter of the amount of data, partly an issue of the type of data, and partly an issue of how the data is being used. As you may know, when we talk about big data, the proposed solution often involves an environment with large clusters of commodity hardware machines. The data and the processing are distributed over all the machines in the cluster. In this type of environment, we need to plan for failure. The assumption is that backups are not possible, so we duplicate the data between machines. Some big data systems default to 3 copies of the data, so now we have 3 times the storage requirement. Do you need a cluster of commodity hardware machines? Let's start with data size. When we talk about commodity hardware, we usually talk about an Intel-based machine. I took a look at the memory and processing capabilities of Intel-based servers today. The maximum memory was listed as 3 terabytes with 112 processing cores. This is likely sufficient to handle data sizes in the dozens of terabytes. I would say that today, a few terabytes of data may not really be big data. Then, considering the historic growth of computing power, memory, and storage, there may not be any reason to worry about outgrowing our processing power. Data size is not the only consideration. For example, if you store a lot of documents or images, you may not do any processing on them. You may only access metadata about them. This means it can take a lot of space, but basically take no processing cycles after being stored. The result is that the amount of data being processed is much smaller than originally thought. Finally, how do you use your data? Do you process it all the time? If you create models, is there a logical separation of the data that makes it more like multiple datasets and models that are related but used separately? Another aspect in choosing a platform is cost. We need to consider more than just the cost of acquisition, but instead the total cost of ownership. This includes the physical space required for the hardware. It also includes the cost of running the system in terms of energy consumption, including any specific cooling needs. Finally, you have to consider the complexity of the solution. How many people do you need to manage the environment? How many people do you need to implement a solution? How long will it take to implement the solution? Is it easy to find experts on the subjects? And so on. So, do you need a big data solution? It depends on your data size and how you use your data. There are many things to consider before you decide you need a big data solution. Consider the questions discussed here and make up your mind. See you next time on Bite-Size Data Science, and don't forget to subscribe.